Okay, so I'm all set. Shall we start? And there are already a lot of Happy New Year greetings from various parts of India. So I join all of you in wishing you a wonderful New Year. It's a part of our tradition. We have Karnataka, Andhra, Gujarat, Rajasthan, and various places, various parts of India. We have our own lunar cycle based New Year's, solar cycle based New Year's, and so on, which is completely different from the Western calendars. It's a great thing, and then lovely to hear from all of you. Happy Ugadi, happy Gudi Padava, and happy New Year. Okay, let's get going. Let's see what are all the things that I wanted to recall and okay. Let's recall that we are going to use elliptic cryptography for our digital signatures. It just means the following: all messages, whatever it is, it's all going to be encrypted as points of the elliptic curve. You have standard, you just give the message and it will convert that appropriately as a point. And every user can have any number of public key and private key. So what is a private key? Private key is simply a 256-bit number. That is all. And what is a public key? Public key is a point. Which point on the elliptic curve you are going to use as your public key? And you may use several public key, because you can have several private keys and you can have corresponding. Every private key will correspond to a public key. Okay. Now, in elliptic curve, the set of all points would generate what is known as a cyclic group. There is one point that can act as a generator of all points by repeated addition. So you take that point and let that point be, so here is that point where my arrow is. Okay, I will, you see that G followed by 04, G followed by 02 is different. G followed by 04, that has got its X coordinate and Y coordinate. X coordinate is a 256-bit number. Y coordinate is a 256-bit number. Put together, there will be 512 bits. All the 512 bits are listed. Okay, this is called the generator G. Whole world is going to use this G. All right, this point will be the starting point. Whole world which is using the Bitcoin is going to use the same curve. Points on that curve. Don't worry about it. We are only 7 billion people. Each one of us can have 1 billion account. Still, you are not even going to handle a minuscule of whatever is available here. Right? You will never have 1 billion account in your life. You cannot handle that many transactions in your life. Assuming that every second you do one transaction and assume that you have so much of Bitcoin, even then, you cannot exhaust this. Like this, the whole world can operate. So don't worry about it. You can have any number of private keys and public key. So what you do is you take a private key. It's a very large number. Just for the sake of illustration, if I say, let's say it is 10, then what do? G plus G plus G plus G, because you have point addition. Scalar, when you repeatedly use the G plus G plus G 10 times, you get 10G. Now you have 1 trillion 496 G. If 1,496 is your private key. Similarly, you can have a large number of, you will have one private key. That many times G is going to be added with itself. G plus G plus G, that many times. It is enormous amount of computation. It's enormous amount of computation. And at the end, you will have your public key. So there is a private key, public key pair. The take-home message is private key is a 256-bit number. Public key is a pair of 256-bit numbers, which are actually points on this elliptic curve. That's all. But from the user perspective, private key is 256-bit, public key is 512-bit. That 512-bit can be represented in a more compact way, but that is all the representation part. Okay? This is your... Now, what is the use of this private key and public key? You can have the signing algorithm, digital signatures. So, how is the digital signature how is the digital signature done? There is a elliptic curve digital signature algorithm. Elliptic curve digital signature algorithm. Oh my God, 1 second. There's so much of noise. I hope you are not getting distracted with that. Okay. So it is called elliptic curve digital signature algorithm. Okay. There are technical details about it, but you don't worry about it. There is an algorithm. What it will take is, this algorithm is going to take, right, the message. The message is a bit string, right? You have a message M. M is nothing but a bit string. M1, M2, M3. It will have some arbitrarily long message. It can be any message. It's a bit string. Message is a bit string. What you do is you first hash the message. Here we are using SHA-256. So the output will be 256 bits. That 256 bit will be the message. So ECDSA will take hash of a message, which is a 256 bit. Okay. The signature should be derivable only by you. It's a permanent, it's a kind of a document is binding with the person who is signing. Strong binding. It's a commitment. So what is exclusive to you? Your signature, but here your secret key. Therefore, the signature is going to be produced as it's going to be a function of the secret key. The secret key. And the algorithm will do something more. It will take some random value, and that algorithm will generate internally. It will use some random value, and then it will use all this information, and then it is going to produce a signature. Okay, it is going to produce a signature. That signature has got two components. S and R. This is 256 bits and this is 256 bits. How the internal works, why this is secure and all are foundations of cryptography. You can learn if you go to a good book on cryptography, the internal details of the signature algorithm and the formal proof, the mathematical proof that this is really solid. It is not possible for you. Well, it's not that it's not possible. It is very difficult for you to forge. You can trust this signature. Be mathematically back. Okay. What is involved in the proof? The probability that you can break is less than 0.00000010. Somebody else kept the mic on. They have to. Someone has kept the mic on. It has to be closed. Otherwise, it will. Okay. Good. Thank you. So, the probability is so low that it is not going to happen, kind of a scenario. That is mathematically true. So, don't worry about it. You apply this on a message. What message you are going to use in, we will see that later. So, 512 bits will be generated. This elliptic curve digital signature algorithm is also open. Source code is available. You can download and you can take any message, simply type some text, okay? And the hash of that will be fed as an input to this. In fact, that computation can also be automated because it is a fixed hash function. That will be also done. So just give the message. The software will first hash it. Then you have to give as an input your secret key because you are going to produce a signature on this message. Okay. And then this 256 plus 256, 512 bits will be generated, and that is going to be the sign on this message. It has got two important properties. No one else can generate it. That means nobody can forge this. Two, after generating and making it public, you can never refuse because this could have been done only by you, not by others. Three, different messages will have different signatures. That it is very rare that you will have the same signature being produced by two different ones. That is because the hash values are going to be different. Typically, right? Therefore, there won't be any ambiguity. Someone cannot fool that the actual message is M dash. That is, right? Integrity check. You present me a check for 1,000 rupees. Suppose I didn't touch your signature. I add some 2 zeros and then change the words, right? 1 lakh, pay the bearer, change the number, but then the change will be recognized. The moment check leave, and what is this? Everything, the words are erased and then rewritten, number, something done. It's a mess. So that check will be rejected. Same way, integrity check is possible. Okay. The second one is this: every signature can be verified unambiguously. You can uniquely fix the verification. That is called the verification algorithm. This is called the signing algorithm. Signing algorithm. There is a verification algorithm. The verification algorithm will take the message, in fact, hash of that message, that will be automatically computed, message, and the public key of the person who is signing, and the signature SR, whether this person has signed this message and produced this. Is SR a signature? Is SR is the signature for M by the person who has this public key, whoever it is. There is somebody who has this public key. Has he generated it? Because there is a corresponding secret key that has generated it. The answer yes will come only if SR is generated by SKA and the same M is used. If M is different, SKA is different, this will all say no. Otherwise, you are going to get no.
Sir, am I audible?
Yeah.
Sir, if you are saying a signature is it's formed after a private key and a message, you know?
Yes.
So, sir, if I am, for example, putting in a message and I'm getting a signature unique for that from my
Yes.
private key,
Yeah.
if I put that same message again, I'll get the same signature.
You won't. You will not get the same message. For the same message, when you sign, you are not going to get the same signature again, because the signing algorithm internally is going to use some additional parameters. They are internal to it. They are random values. So M, when you sign once, you will get S1 or 1. The same message M, when you sign again, you are going to get another signature S2 or 2. Right? This is very important because this is going to protect you. That internal randomness is adding further additional level of security. Right? And one cannot pretend taking this and using it in another context. That will not work. Therefore, every time the signature will vary. It doesn't matter for the verification algorithm. Verification algorithm is going to take this one and the public key and the message. So if you have done and produced S1 or 1, your public key will verify yes for this. Again, you have done, you give M S2 or 2 and your public key, it will verify. Because anything generated by that secret key, that can be undone only by that corresponding public key. Therefore, internal variations and other things are there only for an outsider to give a confused picture. It will further confuse them. It brings in additional randomness. So the probability is made even lower. Already it is low. So it is just to safeguard, we have that kind of a mechanism. What is public key or private key? What is the question? What is that question? There is something appearing on the screen, public key or private key. Which key? M is a plain text. Hash of M. Yes. Verification algorithm will internally calculate hash of M and it will verify that. You don't worry about it. You just give the M to the verification algorithm. Right? Even signing algorithm, you give M. Right? What the first step will be done is H of M will be calculated and it is H of M that is going to be used. So you can consider that as you are giving the input H of M or you are giving M. It doesn't matter. Right? H of M is to make the execution of the signing algorithm very efficient. Because signing algorithm used to be executed several times on a long message. When you try to work on a long file, it takes more time. So H of M is made to standardize 256 bits. That's it. So the signing algorithm is going to have a 256-bit input, its secret key of the user, and it will produce a 256 bits. So the signing algorithm will be compact and run very efficiently. The signing algorithm can in principle be run on the original message, which may run into 1 gigabit. It will take more time. The computation is going to be repeated. It takes a fixer. See, you cannot give a variable length input. For the algorithm to specify, I want this one. I want these 256 bit to be used with this XORed with this. That means I need that fixed algorithm. When it is long, what do? You break them into chunks and individually handle it. To avoid all this complication and waste of time, what people do, take a message here, hash it. Anyway, hash of the message is as unique as your original message. It is very rare that two different messages will hash to the same value. Trillions and trillions of messages can be there. Still, you will not find a collision. Trillions, I'm telling you. Even then, you will not find a collision. Therefore, you see that H of M works. It's like a fingerprint. That's why it is called digital fingerprint. It has got a lot of advantages. The messages are unique. Every person has got something to sign. Right. And H of M is also unique, except that it is having fixed length 256 bits. As on today, the current hash functions we are using are like this. Okay. So the verification algorithm is also available in a built-in as a built-in function. You don't have to, you call it in a particular way, it will work. There is a way to call that. It's a built-in function. Like programming languages have got built-in function, built-in operations. Right? It's signing algorithm because the curve is same. Generator is same. Signing and verification algorithms are same. All are same. What is different is user public key, user private key, user message. That's all. No, every user will, but that can be verified because the algorithm is same for all users, for entire Bitcoin, forever. Okay. So this is not going to be changed. If you change it, you will be in trouble because you have generated something in the past. After 5 years, if it doesn't verify, that's my money. Here is my check. This is invalid. What happens to your money then? So you are in trouble. That's the reason why it is fixed. Completely frozen. Okay. So you have the signing algorithm and verification algorithm. Verification algorithm will say yes only if it is generated properly and appropriate parameters are passed on. Anything else it will reject. Straight it will reject. Okay. If there is a data corruption or some change in transmission error, whatever that happens, if it does not match with that, it will reject. Because it is mathematically, it is going to check some condition. When that is not there, it will simply say no, that's all. Okay. So you have this algorithm. Number one. Number two, we are going to use the public key as the address. If I want to pay, like your account number, right? But this is not an account number. So what you are actually saying is, suppose you want to give 1 Bitcoin to A. What you are saying is, you are going to generate a transaction in which I am the owner of this 1 Bitcoin. How you got that ownership? Through some transaction. So you are going to refer that. I am the owner of this because I got that money. Somebody has given to my public key. Therefore, I am the owner of this one Bitcoin. Okay. And now I transfer ownership to A. How do I specify A? If it is a bank, you can give his account number. Suppose NIFT transfer or any electronic transfer, you give the bank account number that uniquely identifies the recipient. Right? So, the bank, branch, account number, all of them, when you specify, there is a bit string that uniquely identifies and it goes to that person. Right? So, there may be several Krishnamurti and Rammurti in a bank, but how do you distinguish? Right? So, the public key of the receiver is going to be used. Right? I will say that this money is going to be owned by A. I will say that A by the public key. Not exactly the public key, right? The public key hash. Receiver is identified by hash of the public key. There is a procedure. All right. So, the public key of the receiver or the identity of that receiver, you have to either obtain or you can refer in some public place. You have to know that somehow. How that person would have generated? He would have generated his secret key. He would have generated the public key, and that public key is available, and the hash of that public key is going to be made available for the world. Okay, it will be made available. What kind of hash? Here is the way in which the public key is done. Okay, the address of Bitcoin address is generated in the following way.
Oh.
Yeah.
You said that wallet address is the hash version of the public key, right?
Hashed version of the public key, yes.
So it's like we're encrypting it again. You know, like
there is no encryption. There is no encryption. It's hash. That's all. Encryption algorithms and decryption algorithms are completely different. They will call. They are their own algorithms and that have got lot of steps. Hashes are not like that. Hash of a value can be computed very quickly. In fact, in 1 second, you are going to calculate millions and millions of hash values. Millions of hash values you will calculate. Okay? SHA-256 is going to be executed several times, million times, millions and millions of times. In fact, trillions of times you are going to execute in a second. Therefore, hash functions are very efficient. It's only the hash that is going to be.
Sir.
Okay.
Yes,
so
sir, but one thing, one thing.
Yeah.
Why are we hashing the public key if the public key is already public? Like, what are we protecting?
This is just another layer of protection that is given. Public key is not really made public to everyone. Yeah, see, the point is there should be some information that is unique to you should be made public. Public key is intimately related to the secret key. Of course, from public key, you cannot get a secret key. It is already extremely difficult. In spite of that, we are going to give another layer of protection for your public key itself. So what we do is we do the hashing. Secondly, this is going to make things somewhat more compact. Right? That is another thing we are going to get. Our public 512 bits, we are going to make it slightly more compact. We will see what is that it is done. Certain problems are also legacy-based problems where in the initial stages of the setting up of the system, sometimes you have to physically copy, type the key and send it across, and those, because the full-fledged setup may not be available. Now you have QR code to scan. What is your public key? You show your QR code. Your QR code is scanned and then corresponding public key is retrieved by the software and it will automatically do. You have now a lot more sophisticated version, but still the legacy problem of first transmitting that public key physically through the typed, because at the time the user community itself is not known who is who and then what is. So I can accept Bitcoin. Here is my public key. Even now, among ourselves, who are the users of public key? Who are the users? We do not know. Suddenly, you may become a owner of some Bitcoins. I may become. Then we may say talk to each other, and then after a while, I may store it and all. But the first time, it has to be transmitted. Therefore, what is important is we want to simplify certain things there. Okay, so what we do is we take the public key, that is 512 bits, SHA-256, SHA-256 of the public key. That will be 256 bits. Apply on it RIPE MD. 160. That is going to give 160 bits. Okay, double. One is European standard, another is American standard. Okay, one is going to represent the output from least significant bit to most significant, another one from most significant to okay. So a lot of transformation is okay. So this is only 20 bytes. Okay. So this is gone.
If I remember in the last session, we discussed it for each transaction, there will be random private key and public key getting generated, right? So in that case, how can the owner give a generalized public key?
Nobody gives the generalized public key. He will give a public key to which you have to transfer the amount. That's all. Oh. I may have, even now, I may have an account in Canara Bank and Indian Bank and State Bank of India. To you, I may give SBI account. To somebody else, I may give Canara Bank account. That depends on my organization of my finance. So, I will have 250 public keys and 250 private keys. When you are asking me, sir, I want to transfer you one Bitcoin, I will select one of them and give it to you. If somebody else asks me, I will pass on some other public key. Therefore, I may give different public keys to different individuals, different transactions. Right? So, there is nothing like standardized. I am not identified by one key. Whatever I am generating, only I can handle it. And as I have told you already, there is no possibility that two people in the world, even by accident, end up with the same public key. And because what I do is that I generate a random number and I use that as my secret key and I generate the public key. I use another random number. So in this way, I keep generating, let's say 250 public keys and 250 private keys, and I'm using for my operation purposes. Let's say you are also maybe doing some 700 public keys you may want to operate. Another person may also want to operate 1000 public keys. It is unlikely that they will end up as same. That is the random number you use for your secret key in your 1000 attempts. and me randomly generating secret key for my 400, they will all be distinct. Right? Therefore, we are going to assume that no two public keys are same, no two private keys are same in the entire community. Okay. Theoretically, it's a random number generator. There is a possibility of 1.0000080 followed by 1 or something like that. Your random number generation. In that case, you are also using the same formula to generate the public key. I will also. So your public key and my public key will be same. That means anything coming to me, you can decrypt. Anything coming to you, I can decrypt. Because our secret keys are same. Right? That's a big problem. It's a huge danger. No two people should have identical keys at any time. In that case, anything, because it's a mathematical algorithm. Verification, signing, everything is mathematical algorithm. You give the numbers, it will work in the same way. If you and I have the same number, you can imagine the calamity there. That's not going to happen. Right? That is because the number of public keys and private keys available are more than number of dust particles in the universe. Therefore, don't worry about that. Is the mathematical guarantee that is given. But you must be aware of what will happen in that case. In the extremely unlucky event of two people having same private and public key. Right? Anyone can be a loser of the two. So 20 bytes. And then we have a practice. What is that practice? Because this comes from digital transmission, coding and encoding. We will always have whatever we transmit in order to see whether during the transmission things have gone well. We'll have a checksum. Checksum means another bit pattern, which is small, because in a huge bit pattern, if there is an error, that can be detected with a, hopefully the reliable system would have sent a small bit pattern without error, right? Let's say your transmission channel performs very unlikely, but very unlikely. Well, once in 60 bits, you may have some not burst error, rarely. So you can expect a payload of 32 bit go safely. So you can have the verification checksum bit 32 bits if you use. You send 200 bits, but you have a verification checksum 32 bits. The idea is that if there is anything wrong in the 200 bits, long bit transmission, this one hopefully will fix it. Right? But if you are so unfortunate that your hardware has failed, hardware failure, we do not. That is because the transmission itself is checked and rechecked, and then a lot of cross-checkings are done. But in spite of that, because these are all the things in which, even if there is some error, and if it goes to that address, you can't reverse it. There is no way you can reverse it. It's extremely dangerous. It's a complete one way. Suppose you have done the transaction, it is set, that's all. You have signed and then you have given it to that address. But that address had got some error in your reading or. But without verification, then if that is sent, that money is lost forever. The system also cannot recover. There is nobody who can do that. It's a wrong thing. Right? Therefore, the money, and there may not be any user with that kind of an address. Therefore, there may not be anyone who would even claim that money, but then you can't use it because it is spent. You have already transferred the ownership. Just because it is not claimed, the money is not going to be in your, because it is not an account. Suppose you have given a check to somebody. That person has never encashed the check, or he lost the check, or the check is burnt, let us say. Then what will happen? Your money is still in your bank until the check is credited and money is detected. The money is in your bank. That's because it is an account. We don't have a concept of an account in cryptocurrency. We have only ownership. You have already transferred the ownership. You don't know when he is going to encash it. Whether that person is a wrong person or the right person. You have no idea. You have transferred it and you have given it. That's it. After 2 years, even if you come to know that he has not, you can't reuse this transaction. There is no way it can. Once and only once you can transfer the ownership. After that, you lose the control on that. That's the reason why we need what is known as a checksum. So checksum is going to be done in a different way. What they do is, they take this public key, SHA-256, and another SHA-256, and you take the 32 bits of this one, that is 4 bytes. Use that as a checksum. This checksum kind of an information, okay, is there only to check the integrity of the information. It's another way to make sure that things are done correctly. Therefore, what you will send is, suppose you say, hey, I want to transfer you 1 Bitcoin. What is that I am going to send? I'm not going to give you my public key. What I will give you is these 20 bytes and this checksum. That's all I'm going to give. All right? Afterwards, I assume that you properly pay to this address. And you don't have to check all these things. This, when I claim to use, everything will be used. Right? Therefore, what is very important is you have some information and you have an integrity checking information. Both will be made available. Therefore, who am I in the Bitcoin network? I am this 20 bytes and the checksum, which I give to somebody. That's all I am. Anybody who is going to pay money to me is going to transfer the ownership of some of the money they have at their control. Okay. Now, this itself is going to be, that is this information of 20 bytes and then this checksum 4 bytes will be, it will be a byte stream that will be represented in base 58. You know, any number can be converted to any base, decimal to binary, binary to decimal, decimal to hexa, hexa to this. Any base you can convert. If you want to convert to a particular base, you need that many symbols. You want to represent anything in decimal, you need 10 symbols. So you use 0, 1, 9. You want to use in binary, 0 and 1 is okay. You want to use in hexa, you use 0, 1 up to 9, then A, B, C, D, E, F with appropriate interpretation. These symbols are used in hexadecimal system. So I need 58 different symbols to represent the information in base 58. Right? So what is that we are going to use? Lowercase 26 letters, uppercase 26 letters, digits 10. This comes to 62. There are 62 symbols available. Right? There are 62 symbols available. I'm going to remove 4 symbols because they look close to each other and they will confuse. And then when I try to produce manually, that will cause problems. That is the reason why I will eliminate 4 symbols and I will have only 58 symbols. Because I am going to use 58 symbols to represent my information, I am going to transfer the bit string, like the byte string, like byte string I converted into hexa and other things. The complete bit string or byte string, whatever you call it, I will convert it to base 58. then I will have the representation in terms of the 58 base digits. That is 58 symbols minus 4 symbols. So which 4 I would remove? The following 4 symbols. Capital O and number 0. This is upper. And capital 0 and lower L and upper I. Okay. So when you see a symbol, that L and other thing, they get very close to 1. Therefore, this will not. So when you see this, now it is unambiguous. What is this one? This is not 0. This is not digit. And this is not big O. This is only small O. This is lowercase. So if you see this, there is only one interpretation for this. There is unambiguous now because we have removed this from our symbol set. So when somebody sends you this, what will you type? You should type lowercase o. Otherwise, when you see a circle there, you will be wondering whether it is 0 or small o. But by definition, I have eliminated 0, the symbol 0. Therefore, it will be only small o. So, like this, we have the 58 base representation. Finally, your ID or address is a 58 base string. It's not a binary string, and this can be encoded in your QR code. It can be physically passed on, right? You can do the cut and paste, or you can receive it and then you can use it. But what any user will do is he is going to give this as the address. This is the first thing. Okay. This has in it the public key related information. It doesn't have public key as such. It has public key related information. Yeah. What we call? Yeah, what is the question? What is the question? Chat box. What we call? Oh, no, it is called a 58 base representation. That's all. The decimal representation is base 10 representation. Hexa is base 16. But for 58, we are going to take only 32 bits. The output will be 256 bit. Pick the first 32 bit. Very simple. SHA-256, you apply twice. First you have applied the SHA-256 on your public key. Again you apply SHA-256. Take first 32 bits. Only 32 bits. Checksum, I want to keep it compact. So checksum should not be as large as the original one. So what I will do is, checksum, I will take only 32 bit out of that output. All right. So what is that which is going to be there? These 20 bytes and this checksum 4 bytes, 24 bytes, right? 24 byte means 192 bits. So that 192 bit long string, you converted into 58 base. and that is what is your ID. Your ID is always this. It has public key in it. Okay. So this is what we are going to transfer. That is why this is called the pay to public key. Right? Pay to public key. You are going to pay referring to a public key. So you can pay referring to several public key hash. Okay. Pay to public key hash. You are going to pay to the public key hash. That means there are other style of transfer of, you can pay to hash of something else, right? So on. There are many things that you can pay. First of all, we are trying to consider the pay to public key hash. That means we are going to work on an ID or address like this. Okay. So now we are all set for getting into the technical details of the basics. Okay. The fundamental, I'll open up transactions. Transaction is the fundamental unit in cryptocurrency. Transactions are pulled into blocks. Blocks are pulled as blockchain, right? So transactions are the basic building block. And it is the transaction that makes the whole system run. Okay. So what is a transaction involved with? So what actually the user A transfers some B amount of bitcoins to user B. This is the simplest form of transaction. The same concept, the same format can be expanded to A sending in one transaction money to 3 different people. Right? He can send to actually any number of people. It's not a restriction at all. Well, there is a number where that's too large. So you cannot physically type all of that anyway. So typically we will see some 4 or 5 people recipients, and in one transaction you can send to 1 or 2. Okay. So that is called output. So every transaction will have an output, which is going to specify the following detail: amount, and address, to whom this is going to be transferred. Okay, who can take this money? Because it is going to be thrown in public, right? I am transferring this money. I am transferring the ownership to whom? This is what. Okay. So your output can have, you may have several outputs in a transaction. you can have several outputs. This is going to create, I will show you an example. Unspent transaction output. It is going to create addresses the double hash of the public key plus the checksum. That is the address. That's all is the address. Okay. So UTXO means unspent transaction output. Here it is generated. Right? This is unspent transaction output is generated. The whole Bitcoin network maintains all the unspent transaction network. Right? From anybody to anybody, any transaction that is unspent is going to be kept all the time. All unspent transactions are going to be maintained. Okay? The unspent transaction is just a specification. It tells that it is going to be I have some money with me, and that money I'm going to give to this one. So I can specify several addresses and several amount. Okay? Amount 1 to address 1. Amount 1 to address 1. Amount 2 to address 2. Like this, I can specify the total sum is output sum in this transaction. Total sum is, okay, I'm giving all this money from where? Right? There is a transaction that would have transferred something and I own already that. Right? I have to refer to that transaction. So what I have to do is that, let's say, instead of saying A, what A is used. A wants to send, let us say, by the way, 1 Bitcoin equal to 10 power 8 Satoshi. Satoshi is like your cent or something, lowest denomination. Satoshi, 10 power 8 Satoshis. This is 100 million, 1 followed by 8 zeros. 1000, 1 followed by 3 0 is 1000. 1000 thousands are million. 1 followed by 6 0 is million. It's 100 million. 100. You must specify the amount in Satoshi, an integer. You want to transfer 7893 Satoshis. Specify that over there. Okay. The number in Satoshi just don't worry about wallet and the current sum and other things. All right? Just don't worry about it. We will come to that later. All right? Now we are focusing on transaction, structure of transaction, and then how the transaction works. how the transactions are generated, and the wallets are very helpful. They are going to play a role in some of these activities, but you must know about transaction, right? Wallet pushes everything under carpet. It will do many things for you, but you must know what exactly is to be done using the wallet. That's why we have to go to the details of the transactions. So there is a transaction which would have given you, let's say, 1 Bitcoin. What does that mean? There is some transaction for which your address is mentioned and said 1. Somebody has given, let us say C has given to A 1 Bitcoin. There is a transaction in which C has given to A 1 Bitcoin. Now A is referring to this transaction. A is referring this transaction and says, hey, I got 1 Bitcoin, from that, I'm going to give 0.1 to address 1, 0.235 to address 2, 0.1 to address 3. These 3 people will get like this. Then we need to know something very important. This is indivisible. And this must be an unspent transaction output, UTXO. This must be an unspent transaction. And an unspent transaction, once referred in a transaction, it becomes a spent transaction. It is completely disqualified. It will be removed from UTXO. Right? So, there is a UTXO you have, that is not spent yet. In that you have 1, and that is what you are using. There are several situations in which you may not have in single transaction this much money. You want to transfer to 3 people 0.435. This is your current situation. If you have a single transaction in which you got more than 0.435, you can refer that. Otherwise, you may refer to several transactions. From C1, you might have got 1 transaction in which you would have got 0.01. From C2, you might have got another transaction in which you would have got 0.35. From C3, you might have got 0.05. From C4, you might have got 0.1. This is nice. 435 I want. I have 0.4, 0, let's say 50. Okay. C5 has, like this, there are several transactions that now you can be 0.435. No, sorry. That is 0.45. So you can pool these 3 transactions and you can pay this. So you can pool any number of transactions through which you got money. So several persons has paid you over a period of time. If it were a single account, what would happen? It will all happen in a seamless way. Somebody has paid you 1,000 rupees, somebody has paid you 10,000 rupees, somebody has paid you 20,000 rupees, and all of them. So now you see currently how much I have. I have 1,40,000. I can issue 3 checks, 20,000, 20,000, 20,000 each. No problem. There is only one sum that is available because I have a notion of an account. There is some automatic pooling is done. So as long as that is not exceeding, your checks will be honored and other things. And it is asynchronous, right? You can receive money at various times. You can give money to various parties at various times. And here it is. There is some similarity and there is some difference. The first thing that you have to do is you have to collect the UTXOs that has transferred some value to you. These are called the input transaction. You have to refer to all of them. If you don't have a single one like this, if you have a single one like this, it is okay. But if you don't have single one, you have to collect all of them. Right? Now, that is a cumbersome task. How can you remember who has given what day, how much, and all those kind of things, and which is transacted? This is what one of the key helps done by wallet is going to do several other things. Wallet is going to maintain, right, a database of all UTXO, which is transferring the money to you. You means what? Your public key and your private key. How does the wallet know your public key and your private key? Well, it is wallet that is generating it. Therefore, it will know. And you might have given to C1 one number, C2 one number, C3. All these things you would have done in the past. So they have done all of them. So wallet knows. So wallet has a table of information. It's a very powerful software managing a lot of complex tasks. The first thing it has is, right, it has got a beautiful interface, user interface. In that user interface, there will be two boxes only. How much money you want to transfer, to whom you want to transfer. Is it 1 or 2 or 3, whatever is the number of persons. Let us say we want to transfer to one person. Right? Let us assume that we want to transfer 0.435 to address 1. So in my wallet software user interface, I will put the address and put the money. 0.435 I want to send. And what the wallet is going to do is, for you, find out various micro payments that have come to you over the past, add values that you have received, which is just exceeding 0.435, it will collect, and it will, after a second, it will say, yes, you have sufficient money, and I have pulled all the transactions which will sum up to this. It will say that. So you don't have to worry about it, but then you must know that wallet has done something like this. Often we will go to that, but then now we will see what is to be done. So you can have multiple transactions as input, multiple transactions as the output, but for everything, you have to do the same thing which I'm going to say. Therefore, I'm going to assume a transaction which has got single input you are referring to, and you are giving to one. If it is multiple, the same thing which I am saying is to be replicated for each of this. Therefore, it's going to be the task that we are going to understand. So this is called the input transaction. There is a transaction, okay, in which you got some money. How to refer that transaction? Like you have the address, every transaction has got address. We don't call that as an address because it is not an individual. It's called the ID, transaction ID. Transaction ID is hash of the content of the transaction, that whatever bits, every transaction will have input, output, a lot of things are there, you know. The transaction ID is a hash of that and some piece of information. We will see later, that's not. So every transaction has an ID. So what is it? You have to refer to this transaction. There is a transaction, okay, in which there is some money transferred to this transaction ID. Let us call this as transaction T. This T is from C to A. A is referring to this because based on the ownership he got from this transaction, he is going to give it to B. So before giving A to B, what A has to do is he has to refer a transaction through an ID. He is generating a transaction now, but to generate the transaction, he has to refer a transaction which transferred money to him, money to A. We are now looking at the process of creating the transaction by A to B. So what A first does is, right, he is examining in what are all the transactions in which he means his wallet will do, but then let's identify, let's say he has identified a transaction from which he is going to use now to generate this transaction. Let us assume that the transaction is from C to A. So C to A, that transaction generated by C may have several outputs. One of them might be A, right? So this transaction may be generated by C, and this transaction may have several outputs. It may say give 0.52 x1, give 0.72 x2, give let's say 0.52 A, give 1.22 B. Like that, this might have specified various outputs. A got the ownership through this transaction, and this is the third output in the transaction. You are going to number that serially. 0, starting from 0. So this is 0, 1, 1, 2. So A is going to refer this transaction, and the output sequence in the transaction, and he will say that, hey, through this I got 0.5, of which I am going to give you 0.435. Right? I am assuming that A wants to transfer 0.435 to B. A has identified, or A's wallet has identified a transaction through which A got 0.2. That's somewhat closest to it. There may be a transaction with the 5 Bitcoin. That also can be used. Anything larger than that can be used. Input should be greater than output. That's all. Is the only condition. That the wallet will verify. It may pull 2 or 3 transactions. Similarly, there may be another C dash would have transferred, okay, in another transaction T dash would have transferred to A, but then he might have done in this transaction 0.42 x3, 0.22 x4, 0.6 to x5, 0.01 to Y, 0.25 to A. But here A's transaction serial number is 0, 1, 2, 3, 4. Let us say this is also 0.25. If it is 0.25, the second output of T and the fourth output of T dash, take both. Together it makes 0.5. Now I'm going to use that 0.5 to enable this transaction of 0.435. That is how you are going to, A is going to say, I have got some money through T, but the T has a lot of details because he has to transfer to several people. I'm one of the recipients, but anyway, I am a recipient. I'm the third recipient there and I'm the 6th recipient here. Whatever it is, I will refer to my part in the transaction. So the transaction ID will be given, and after giving that transaction ID, in that ID, which output corresponds to A, that also A will specify, and this information is available in public. This information is available in public. Okay. So even I can refer to that transaction. But what that would have said in the transaction, this goes to, there is a public key of A. This 0.5 transaction is meant to the person with the public key something, PKA, let us say. That is what this transaction would have specified in its output. What is the output saying? Output gives two pieces of information. There are a couple of more. We will focus on that later. Value, address. These two will be there. So C in T would have specified 0.5 and he would have said the address of A. How the hell the system will know, or the world will know, it is A who is trying to use that money. It is A who is trying to use that money. Why not I see that? I can also use that money. I can pretend as if I am the recipient. Right? A may not know, A may be sleeping. Right? Now A may be in Japan, but it's already late in the night, he is sleeping. Now I want to use his public key is there. Right? But I don't have his UTXO is not like account balance. UTXO is should not be connected with any concept of account. Right? Unspent transaction output. It is referring only to output. It's not even referring to input. You can see that. UTXO. Therefore, do not. Right? UTXO is the current state of your ownership. It is not spent. You not only own it, you have not spent it X. That is why it is called unspent transaction output. The moment you use it, it will be thrown out from the UTXO list of the whole world. Every system is maintaining all UTXOs ever generated since the creation of the Bitcoin. Right? It will maintain only UTXOs. Once it is spent, that can be thrown out. It will not maintain. Right? It has become a part of a transaction that is going to be in a block and then that's already gone. But UTXO is saying that that money is available with you. In fact, this transaction says 0.5 is available to X1, 0.7 is available to X2, 0.5 is available to A. Only A is using his part. That's why this output is currently going to be spent. There are other outputs. They are not spent yet. X1 can refer the same transaction and he will say, the first output in the transaction, I am the owner. I want to use 0.5. X1 can independently generate another transaction to Y1, referring to the same transaction. But then what he will refer? He will refer the output, that is output serial number. There is one output that corresponds to X1, that is serial number 0. For A, the serial number is 2. So A will refer to 2. In that transaction, through the output serial number 2, I got 0.5. I am now going to use it to generate this transaction. But anyone can use that. So how the world will know that it is A who is actually using it? This is where signature comes into picture. Okay? Now, A is going to use his secret key and sign this portion. There is a bit physical part of that. Right? We are going to see that in a transaction. The physical part of that he will sign. Right? If he signs some other part, hey, there is 0.7 here. Why can't I grab that 0.7 from that? In Tamil, there is a proverb. If you know Tamil, you can understand what this is. Right? This means the following. He didn't buy he wants to offer coconut to Ganesha, not Ganesha. What he did was there was a coconut vendor. He pulled out one coconut from there and he offered it to God. Neither he bought the coconut nor he is the owner of that. He has simply pulled out from that and then offered to God. Okay, so that's attitude is wrong, right? So I'm seeing in this transaction, I own only from second, but then hey, that's 0.7 is there. Why not I use that money? If you use, you don't have his secret key. You have only your secret key. If you try to use your secret key and try to do something with that in the verification process, it will be rejected. Therefore, whatever is meant for you, only you can sign, because your public key is maintained, is mentioned in only in the third transaction. Serial number is 2 because we are indexing from 0. A public key. C has specified public key of x1 in output 0, public key of x2 in output 1, public key of A in output 2, and public key of B in like that. He has several things, but A gets the right only through the third output of the transaction. That alone he can touch. That part he is going to sign. Okay, and that will be the input part. So the input part is going to have a transaction ID and a relevant portion of the transaction ID signed by A. This will have. Therefore, every transaction will have input and output. Notice that the input has got only transaction ID. It doesn't tell you how much money it has. It doesn't tell you how much money it has. Right? So, if you refer to a transaction ID, which is giving only 0.25 and use it to pay or use it to generate an output transaction with 0.5, it will be rejected in the verification process because you are referring to transaction. And in the transaction, that is the reason why if you don't have sufficient money, you must use multiple transactions as input. Here we are assuming, for the sake of simplicity, only one transaction and one output. You can generate using the same transaction. You can use multiple input transaction and multiple output transaction in a single transaction you generate. You may refer, C has given me something, C1 has given me something, C2 has given me something. I am pulling all of them. I am using this money to pay X something, Y something, Z something. You can say that in a single transaction. Right? But let's see what is involved. For simplifying the discussion, we are going to refer one transaction, assume that that has sufficient money. At relevant part, sign, you are going to put as an input. So your transaction has been generated. Your transaction has been generated.
So one doubt. So let's assume I've got 1 Bitcoin.
Yeah.
I've not spent it. So the whatever amount I've got is in UTXO, right? Unspent transaction output. Since I have not.
Right. Yeah.
So let's assume I'm transferring it to you.
Yeah.
Then the money goes to you. Then still it will be in the UTXO, right? Because you become the owner of it and it becomes unspent in your account. So
no, that is a different one. That is a completely different UTXO.
Okay.
In this UTXO, there is no balance or nothing is to be maintained. Why? This UTXO is signed by somebody else. This money, one Bitcoin is going to be, was a owner of somebody and he has transferred it to you. So you can't put anything back into this. The balance you have to own or pay yourself back. I will come to that in a minute. I'm going to answer your question. This UTXO is destroyed because this is generated by somebody. This object belongs to someone. That object you have broken, right? Therefore, this object doesn't exist anymore. It is a spent transaction. Permanently, the status is changed. Yeah.
Is it because the UTXO, when the new UTXO is created, it is because it is going to have a different signature?
Yes, because it is the
Okay.
ownership is different, right? Now,
Yes, sir.
one is owned by you. So your signature and your transaction is to be validated to handle this object, not anymore that person. That is the reason why the UTXO, once is spent for. That is why it is an indivisible unit. You cannot split it. You can't refer to this and say, let us say you have 1 Bitcoin transferred. You can't refer to this and say, today, take 0.3. And you can't imagine that 0.7 is still there. And 2 days after, you take 0.2 from that. You can't say that because that one is generated by someone. 0.7, that he owned 1 Bitcoin. He doesn't own 0.8. From 1, the moment you give 0.2 to somebody, 0.8 is there. But who is the owner of that? You are the owner, not that person. That is the reason why this 1 Bitcoin transaction is considered as spent. The state is permanently changed. Therefore, you have to be careful. What is that you have to do? I will tell you what is that you have to do now, because it is indivisible. Okay? Because it is indivisible, what is that you have to do? Suppose you are generating...
Sir, if we spend only 0.5 Bitcoin from 1 Bitcoin, right? So then a new UT actually will be generated for 0.5 in my account?
That is right. It is going to be generated. You have to do that. That's what I'm going to tell you now. So you are referring to a transaction that gave you 0.5. Okay. Let us say you would like to give out of which 0.4. Let's simplify the arithmetic. 0.4 to B. There is a balance of 0.1, right? That balance of 0.1, you must generate a transaction to pay yourself back. You must pay yourself back. Otherwise, what will happen? A disaster will happen. I will tell you what that disaster is. Okay? So, your output transaction will have the following. It will have 2 outputs. One output is give 0.4 to B. You will specify this address and say, and 0.1 back to me. But how do you say back to me? This also you have to say, give 0.4 to an address that belongs to you. You can give that any address that belongs to you. To address of A. So A has to generate a transaction. This must be specified. I will tell you why that should be specified in a minute. All right? You can give any of your address. You can give any one of your address. So this is going to generate a UTXO with 0.1. Somebody has transferred, that doesn't matter. A UTXO with 0.1 to that particular address will be generated. Therefore, for every output, a UTXO is generated. Now, this one will generate 4 UTXO. It will generate 4 UTXO. And C is referring to some transaction, 1 or 2. All those UTXOs will be deleted. These 4 UTXOs will be created and maintained by the world. 10,000 Bitcoin network systems, they will have UTXO set. All of them will delete that, will create this. So when A is generating this transaction to B, A is referring to some UTXO under his control. There is a UTXO that has transferred some 0.5. That UTXO will be deleted from the UTXO set, and 2 UTXOs will be created. This will be created and this will be created. And both will be created and both will be flooded in the entire network because all of them are maintaining the UTXOs. The wallet of A, when it is spread, will capture this and then pull it in it. The wallet of B will capture that and then keep it in its custody. But these 2 UTXOs are generated and then sent. I mean, assuming that everything is valid, these 2 UTXOs will be generated. Okay? These two.
In that case, given a time, UTXO set will have the X number of Bitcoins available in the world, right? It would
Yes,
always be the same number.
Right. All UTXOs are unspent transaction. It is like all our bank balances in a bank.
Correct.
Right? You have some balance, I have some balance, but the state bank will have all balances. That is the unspent money which is available in the system, of which I have control for. Let's say in my account I have 50,000. Of the money available with state bank, I have control over 50,000. That I can give it to you or he or she, or that's up to me. So it is like that. So the unspent bit under your control is maintained in your wallet by you, right? All the UTXOs are there, okay, which are relevant to your address. You can use, right? So point 1, give back to me, is specified by A by giving an address. A may have several addresses. That give back, he can give any one of his address. That will make sure that that point 1 comes back to A. It is technically going back to A. It is technically going back to an address. That address is owned by A, therefore it comes back to A. Right? This is very important because the system operates in the following way. All the transactions are pooled in a block, and the block generation requires a lot of effort. Therefore, the block generation, which is done by miners, they need incentive. Okay, they need incentive. Why should somebody maintain and manage your UTXO and then verify, validate, and put in that, and then put in the blockchain and maintain the blockchain? There must be some incentive for that person. That is the reason why every transaction has got a transaction fee. There is a transaction fee that goes to the miner who generated a block that includes this transaction. That includes this transaction. This T is included in a block and then in a blockchain by one miner. Some miner has done it. For him, a transaction fee will go. You have to pay the transaction fee for them, but you don't know who is that guy, because now you are generating a transaction. You don't know when it will be getting into a block. Who is the block generator? What is his address? You want to give transaction fee, but then to whom you will give? You can't specify the address. You don't know the person. You know that A knows that he has to give 0.4 to B. But then he doesn't. There is a transaction fee, but to whom he will give? He cannot specify the address. Therefore, what the system has done is there is a default mechanism. Okay. Sigma input minus sigma output equal to transaction fee. Sigma input minus sigma output is the transaction fee. Right? This transaction fee will be calculated by the miner, and the miner's address will receive this transaction fee. The whomsoever has done it. You don't have to specify. You must specify the address of B, address of A, and other things. But you don't know the miner. So how will the miner get the benefit? Whoever mines and then whoever does whatever the maintenance and bookkeeping, everything for you. There is one individual who is doing all of them. How will he be paid? He will be paid by this calculation. He will be paid by this calculation. So what actually you should do is, you must bear in mind the transaction fee, right? And work out what you are taking back accordingly. For example, give 4, if your intention is to fix a transaction for this is 0.01 bit. Bitcoin, right? 0.01. So don't take 0.1 back to you. Take only 0.99, give back to me. So your output, your input is 0.5. Your output is 0.4 to A, 0.99, 0.09 to B, to back to me. This is how your transaction will say. Your transaction is going to say this. Automatically 0.4 will go to you, 0.09 will come back to you. Then what about the difference? The difference will go to the miner who has processed your transaction, included in the block, broadcasted everything, put in the blockchain. For all of them, he is going to get some fee. How to determine the transaction fee? If you write this as 0.1, as I did earlier, input equal to output, the difference is 0. Since the difference is 0, the miner who is verifying the transaction may not be even interested in considering your transaction in putting in the block, or he may put in a low priority. A transaction which is not put in the block, you cannot use the money out of that. Therefore, if somebody has to take interest in it, you must make sure that you are giving a transaction fee. There are recommendations depending on the size of, it's not depending on the value, it is depending on the size, because there is a block size limitation. A block cannot have more than 1 MB of data. So in one block, depending on each transaction has size. If he is able to pack, let's say, only 100 transactions, which 100 transactions he will pack? He will obviously try to pack the transaction that is giving a lot of transaction fee. So top 100 he will take, he will try to pack, and then he will try to make a block out of it. Whether he is successful or not is another story. But then the way in which he is going to select a transaction for inclusion in the block, so if your transaction fee is too low, miners may not be interested. Therefore, your transaction getting into the blockchain may get delayed. If it is appropriate level of transaction fee, then normally it will be considered, and then in a good priority basis, it will be included in the blockchain, and it is verified, validated, and then approved. So B will get quickly. Otherwise, you may have generated a transaction to transfer from U to B. When B will get it? Actually, only when the transaction gets into a block and goes into the blockchain, and even after going into the blockchain, about an hour. Right? But if your transaction fee is very low, right, the miner may not take it. That 0.01 to a miner is not UTXO, right? It is automatically credited. See, there is he is generating a mechanism. He is generating when a new block is created. I will tell you about it. There is a block incentive generated by, he brings in some money into that. With that, this will be added, because it is not a UTXO in the sense the address is not specified. UTXO requires the address to be specified. Therefore, with the block incentive, transaction fees all added up with the transaction will be, and then that money he will own, because there is a block that he creates. With that incentive, this will be added. I'm going to show all of them in a short while. I'm going to show this. Therefore, 0.1 will go to the miner's favor. How it goes, we will see. But the point is, whatever is the difference between input and output will automatically go to the miner. The system is designed to work in a default mode like that. That is interpreted as a transaction fee. So if you don't try to give this back to you, if you forget this, nothing will happen. 0.1 will go simply to the miner. That's huge money. You may break a transaction which has got high bit value. That will be a lot higher than output. So it will go through. But the difference between the input and output is always considered as a transaction fee, and it goes to that anonymous person at a later point, whoever is making the block, that is including this transaction. Therefore, if you are negligent, yeah, I will come to that. I will show you how the miner going to use this 0.01. I will tell you. Okay. Therefore, this is very important, giving you back. So make sure that input are all added. You get alpha. Output, whatever you want to give, beta. Then determine the transaction fee as per some standards that are available. There are recommendations available when you are generating this transaction. In fact, most of the wallets will have some transaction fee calculator, which when it is generating this body of the transaction, it will have roughly the number of bytes, byte, Satoshi per byte. Formula will be there, and accordingly it will calculate, and then it will reserve that much money for transaction fee and generate one more alpha minus beta minus transaction fee as give back to me. Balance back to me with this value would be given. Therefore, the difference between input and output is always transaction fee. Therefore, be careful about the transaction fee calculation and make sure that you are getting back the money. If you don't have the last transaction as give the balance back to me, everything will go to the miner. Okay. Now, let us see a particular transaction, and then we have to explain various other things about it. But let's first see the transaction and comment on all your questions are going to be answered now. Okay. So I have shown block 5 lakh. Right now, in the blockchain, there are about 7,30,000 blocks are there in the blockchain. I am now giving you I am showing you the picture of block 5,000. Okay. How do I close this chat? Okay. This is block. This you can see. Where can you see? You go to Bitcoin Explorer and then you type in the search, you type 5 lakh, then it can give you the, I think that's what I did. Yeah. Oh, wait a minute. What is that I did? In the blockchain.com, there is a search. You can search in any block. See what I am doing. I am typing 5 lakh, 5,000, 50,000, 5 lakh return. So this is showing the current block, but I want to go to a block 4 years back. There is a reason why I am going to that. I will tell you the reason later. Now, the 5 lakh block in Bitcoin. So this is the block 5 lakh. That block, okay, that block was generated on December 19th, 2017. You can see when this was mined. This is the date at 12:05 a.m. Okay. The miner who has created the block has got block reward 12.5 Bitcoins. You can see how much money is. That is close to $6 lakh, right? 583, right? More than $500,000 he got when he generated this block 4,000 years, 4 years back. When he generated it, he got it. And then you see the miner got a reward of this and additional reward 3.39351625 reward paid as fee of 2,701 transaction. 2,701 transactions were included. Each included transaction has given some transaction fee. All those transaction fee will be added, and that will be also given in addition to the block reward that he has earned, right? That means it is a total of 14. How much he got? A block reward is paid. Therefore, this fellow is now having in his account, because he is a miner, he also has an address. When the block was generated, the block incentive will be given to the address of the miner who has generated it. With that, this transaction fee also will all be added and then given to him. Now he has at his disposal 12.5 plus 3.39. This 12.5 he has, and 3.3935, this much Bitcoin he has earned. Actually, the block reward is dwindling, right? In order to keep the inflation at bay, the designers have, now they are getting only 6.25. Little later only 3.125, and it will taper. And in 2042, there won't be any block reward. No more new money will be created. Now, the miners will survive only on the transaction fees. So the transaction fee is expected to become slightly higher as we go along. Right now, this is what has. So here is a block. Now you see where the 0.01 had gone. It is all pulled together and credited. So there is a point at which the system credits to the, that's why this is called coin base transaction. This is not a transaction generated by A to B, or there is no transaction involved, but the money comes to the person, right? That's why it's called the coin base transaction. And in this new money that is generated, transaction fee all added, because transactions all are anonymous, right? They none of them specify the address. So where does that money go? All the money will go to this fellow. So you can now see it is generated on this. To difficulty, all of them we will see later. Okay. And transaction volume. How many Bitcoins are involved? There are 2,000, each transaction 0.4, 0.5 like that. So 14,017.37 Bitcoins are transacted in this block through 2,701 transactions. And this is the fee reward, 3.39. Okay. So let us go to a transaction, right? Simply go to the transaction. This is the transaction ID. Okay. Click on the transaction ID. When you click on the transaction ID, you will get the content, right? What is the size of the transaction? 372 bytes. It says the transaction. Okay. It is included in 5 lakh block. Okay. Now you see what this fellow has done is he is referring to 2 inputs through one transaction. That is a transaction ID. You can click on that and go to that transaction and then see. All right. He has one transaction ID through which he has got 0.0491197 Bitcoin. There is another transaction ID in which he got 0.0807. Here, this region. I am reading this region. These are the inputs. And the total of the input, when you add these two, you are going to get 0.129, something like that. Yeah. See, the total input, 0.129871114. This is the total input. Through 2 transactions which he got, this is the total input he has. Okay. And now, what about the output? He has given to 2 people, right? This is the address. Right? And in this address, he has transferred to one person 0.0000693 Bitcoin. To another person 0.129000349 Bitcoins. So he has generated 2. You do not know whether the second one is some other person or it is back to him. It could be anything. It is just an address, that's all. Right? It might be one person and the balance is back to him. Or it could be 2 person who total is very, very close to the input value. It could be either way. But whatever it is, there are 2 outputs and their values are given there. So the total output, you add these 2, you get 0.29, 12969, something like that. That is what. Right? This is the total output. This is the total input. Total input minus total output is transaction fee. That is what the fee. So you can see this is the fee. Under fee, you can see that 0.0017463 Bitcoins is the fee. That's the fee per byte and all those things are there. Right? Value when transacted, $2,381. Okay. That's okay. That's aside. So what is important is you can see that total input minus total output is the fee. This information will be generated when the transaction is validated. When the transaction is validated, you check whether this output is belong to him, signature verification, everything you will do. So there the values are all visible. And the verifier will generate, and the verifier, everybody in the world will know that if they include the transaction in their block, every miner will know that they will get 0.0001746 Bitcoins. That they know. So what they do is all the unspent transactions, when they are verified, the sum input minus sum output, which will have the information related to fee, will be known. So naturally, the miners will pick the one that is giving a lot of fee and try to make a block out of it. Right? When the block 5 lakh block was formed, when people were attempting, there will be large number of unspent transactions. Right? And then large number of transactions which are generated like this. Now, these transactions, which one they will include in the block? Why did the miner of the 5 lakh block decided to include this? He finds that this fee is attractive. So who will create a block? We are going to deal that when we are discussing with miner. Anyone can create the block. Any person who is in the Bitcoin network is eligible to create the block. Whether you manage to create or not is depending on the race you are in. Much like you, as you can see, you are going to get $500,000, more than $500,000 when you create a block. Do you think that there will be only one person who will be attempting to do that? Obviously, there will be a lot of people out in the world will keep trying to generate a block. There will be only one winner. And that fellow will get this money. How that is decided, we will see later. Mining, block mining. After block mining, blockchaining. All those things will come later. Right now, we are now looking at the transaction part, which is generated by individual to individual. There are other kinds of transactions. Individual to script, and we have to know what script is. We need to learn some more stuffs here. Right? You can look like this in any transaction. Every transaction, the detail of that, actually transactions are not presented in this way. This is a graphic user interface. The blockchain.com or blockchain explorer is a piece of software that allows you to look into the content. How will it be in the original? It will be in a form called serialized form. Serialized form means there will be only bit string. Don't worry about the weight. There are several other information. We will talk about them later. Right? So WU, all those things are there. So you can see PK script, sign script, everything is there. Address, PK script, sign script. We are going to discuss. These are important things to do. So we can see. I've chosen one transaction. There are 2,700. They're all listed here, one below the other. So you move. Let's go to fourth. Okay. So here is a transaction. Just press this. This is another transaction. Its size is 399. It is included in the same 5 lakh block, included in block 5 lakh. Okay. And total input is 0.15. Total output is 0.135. The fee is 0.00148. You can see that this fellow has paid this fee, this much fee for this transaction. All right. These are all the inputs. All right. There is only one output. So rest of them is input minus output is the fee. All right. You can see that in this case, there is only one output. He managed to find out 2 transactions which had almost very close to the requirement of to be sent. So he has just only one. So the only one output. So input is this much, output is this much. That's all is there in the transaction. The difference is transaction fee, and that will be taken automatically. That will be credited to the miner, whoever is the miner. Who is the miner is also, that information is also available that you can check, although I didn't project that here. Oh, sorry. This is mined by btc.com. This block was mined on December by btc.com. Okay. All those things. Okay. The transaction fee and block reward 12.5 Bitcoin were sent to this address, to which address all of them have gone. There is that address. You type that, you get that address. This address has transacted 948 times because he is going to sell all the Bitcoin that he has got. Right? He's a miner, and either through merchandise or somebody who wants to buy Bitcoin. Right? He has the newly minted Bitcoin with him, and he will give for dollars, whatever is the prevailing market rate. He will transfer it to your address. From this address, you will get it. You pay him dollars, and he will transfer you this much. In order to facilitate that, you have exchanges and other things. There are other administrative setups which will connect the user with the miner, and you can do that. In the same website, can allow you to buy, transact, buy, sell Bitcoins. Okay. So these are all some of the details, as you can see in the all are open. You can see that whatever has happened in December 2017, I am able to analyze what's the content. I may not know who that is, but I might even know who that is in the following way. You can see that I can search by the transaction and by search by the address. This address is involved in 940 transactions. So we can search by an address also. Suppose you gave some money to me. I know your address. From that address only I got this. Your signature, everything is there. Since I know that address, I can search that address, and whatever that you have used to transact, if you used that for 10 different people, I will know that you have interacted with the 10 different people because the same address is used. That is the reason why for each transaction, you better use a different address so that you may transact with me. But then if I do some search with that address, only this transaction will be there and nothing else. So you might have actually transacted with 100 other people, but they are all with a different address. So this search will yield only, so nothing more I will get. Right? So, but there is a chain of chasing because the last transaction might be back to you. In that case, what I will do is that I will check that address also to whom you have given. And so some investigation and search always people can do. But in order to remain as anonymous as possible, what you have to do is for each transaction, use a different address. It's a complicated process, but then your software does it. Your wallet can do it. So the wallet has a user interface for giving back. You want to use existing address or you want to have a new address? You say press new address, it will generate a new address, and to that new address, the give me back will go. And it will maintain all the addresses generated by the wallet, which is you. Therefore, wallet can maintain without any problem a table where all transaction and the money in each transaction available to you. So if you want to transact 4 Bitcoin, from that money, it will add up to just above 4, pull out those transactions and create a new transaction. Right? So all these things can be done. What is important is how the system knows that this is a transaction that you own it and you have the authority to transfer it to somebody. We are going to say that. Serialization is, you have a lot of, let's see whether, now you see that when I have a transaction, when I press this, you get this information. All this information, the address, the amount, and they are all put together in some bit sequence form. The raw transaction will be a bit stream, but it has got field and then it has separator. Everything is there by default because it is fixed sized one. You will not be humans can also dissect it and then would know. If you know the technical details of that, you would know that. That's a raw form. It is called the serialization of data. Serialization is done purely for internet transaction because there you want the bits to go from one system to another. It is your perception. This user A, this is his address, this is a data, and then you have a table and all those information. But ultimately, when the data is traveling to the network, it will simply go as a bit stream. Therefore, the raw transaction, which is transmitted, verified by everybody in the world and stored, is a serialized version of all this information. This is a user-friendly, structured form of information. But the same information is in the blockchain or in the physical one in a completely different way. It will be difficult for a human to decipher it. It's not impossible. If you know the technical details, you will know, because the conversion. Therefore, don't worry about it. Serialization is for advanced, for the developers, and then for checking the internals and the working you will need. The non-technical users. Okay. So if you are technically strong, you can download. This is online tool. Okay, Bitcoin Explorer, Blockchain Explorer, and bt.com. All these all will have the user interface which tells the content in the. But if you want to have your own, you can download any one of them and then install that Bitcoin client and work on it. It's easy, but you must know how from the open source servers download the software, store internally and organize within your operating system, and then create the executables and install the software. Once that is done, that has to be done almost for anything. If it is app, it is very simple. But if it is any other, for example, you want to have a new word processor, that requires installing, downloading, and other things, and learning the font and operational details. Same thing. Okay. So we are going to take a look at this part. Which part? Where are those inputs and outputs? Oh, I'll give you another. This one seemed to be.
Sir, in the given example, what we are trying to look is the 5 lakh block, right? In similar way, can we see the Genesis block? Who owns it now? Is it possible to look something like that?
Yes, you can see the Genesis block. Right now, you can see the. I want to explain this part, right? Input and output, address and value peak scripts that we are going to see after the break. After our, we are going to take a break. It's 8:17. 8:20, we will come back at 8:40 and then start some discussions on this. Okay, we need about 20 minutes break or 15 minutes maybe. 8:35 we will come back and then continue with this discussion. If you want to go to the Genesis block, all you have to do is go to the Explorer, search. This is within the block. You go even back to that Bitcoin Explorer, Ethereum, no, Bitcoin Explorer. Okay, search. One. Okay, Bitcoin. This is block 1. Okay, this is the Genesis block. So you can type 1 and you get to block 1. This is a user interface, right? Therefore, this gives you a lot of This is the content of the Genesis block. Everything you can see when it was generated, January 9th, 8:24 a.m. Okay, by unknown. Okay.
Sir,
All those, yeah.
what is meant by confirmation?
Confirmation.
Is there,
No.
yeah.
Confirmation means that we are going to discuss when we are introducing the blocks and blockchain. That is the number of blocks that has been generated and appended after that point. If the confirmation is 10 for your transaction, means the following. Your transaction is in the block, let us say 49. Now you have 59th block on the work. After 49, 50 is generated and appended in the blockchain, right? That means 10 more blocks have been added. That's what it means. Confirmation means how many blocks have been added beyond the block that you have. The reason is more the confirmation, the mutilation is hard, because any change has to be accepted for all that confirmation that has been done. Even if you change one with the hashing, collision and other thing, making the data to work same is difficult. Even if you have made it for one, it need not follow for the other one. When the other one checks, it will be different, and unless you are capable of changing the whole thing to another block which has got equal one, which is impossible task. That is the reason why more the confirmation, more permanent and secure your record. The current under the probabilistic and the simple model, if you have 6 confirmation, you can take it for granted that your record is permanent. Right? So these kind of questions I'm going to answer when the mining is done and blockchain is formed, right? And this is where the so-called consensus protocol, everybody should have the same copy of the blockchain. The situation is like this. There are several people who are attempting to create a block. Suppose there are 2 people who are successful and then they are broadcasting their blocks, right? Let's say a guy in Singapore is sending his successful block and a guy in Canada is sending his successful. So people in US and other thing will get that block first, and then they will append and extend their blockchain with that one. I would append, but later on I will get that, and then those people will get Singapore's. Now there is a confusion, right? Which one is to be considered? So just because it has entered into a block, don't immediately feel that it has been confirmed. Wait for the stability of the system. Because a block that has been added may get deleted and the transaction can be again pushed back into the memory pool and so on. And so at the current end level, there can be a disagreement. Some chain will have some block, some other chain will have some other block, and other thing, that could be a variation. But there is a stable part in which the whole world will have identical copies. Ideally, we would like to have the identical copy, but it is an asynchronous system and different people are doing in a peerless, controlless manner. Therefore, the extending part will have some variation, but then there is a way to make it synchronous. That is agreement or consensus protocol. According to that consensus protocol, see, let's say all of us have got 99, but some of them will have something else as 100, but there must be a mechanism in which all of us will have identical 100th block. That will be done. In the meantime, 2 more blocks would have been created, and again, your 101th block may not be same as my 101th block. Somebody might not have received even 101 at all, and he will receive 102. And oh my goodness, then what is happening here? So these, at the current end, the synchrony is to be done. But then the stable part, 1 to 50, is so stable that that part is not going to be changed. It's all done and then frozen. All of us have agreed. Consensus protocol has worked. And we are now, the confusion is in the current end. So when will you become a part of the stable part of the blockchain? After about 6 confirmation, you can take it that it is very unlikely that your block is going to be disrupted and everything will be pulled back and other thing. That kind of a thing can happen for the blocks in the front end, but not the stable part. That is the reason why confirmation count is given. If the confirmation count is 6 or more, you take it that things are confirmed. Until then, it's good, it's acknowledged, verified, but still the transaction may not again find a permanent place yet in the blockchain. It might be part of a block which may be deleted in the consensus process. So those things we will discuss when we are talking about consensus groups.
Sir, in the very beginning, you discussed that let's assume an address which does not exist have transferred money. Still, the transaction happened and the ownership has been transferred to the address, right?
Yes.
So as the address does not exist, where would the money? Where would the Bitcoin?
It is lost. No, it is lost. There are untraceable Bitcoins of that kind. Because in the early days, people were a little careless and Bitcoin was not dissolved, and then the system error and many things have happened. There are unclaimed and untraceable Bitcoin is there.
Okay.
See, for example, let's say shady characters keep all their things, let's say a rowdy element has collected his cash, and then somewhere when he has gone way big place, he died, and then the money is also drowned or something completely. That cash is lost, right? And it's not traceable because he, let's say he was going in somewhere to island and his boat capsized and he and his money, everything went down the sea. Let's say he has $100,000 with him. He died. Nobody could trace him. He has not left with any contact. And the money he carried also drowned in the sea, gone forever. Right. So, like this, there are always untraceable money will be there in any system. Unforeseen expenses. Here, it's all due to wrong address only. There is no other way in which, of course, if somebody has an address, he has a secret key, he died in an accident. There is no way the secret key can be recovered. There is some money in his account, but then no one can trace it. No one can recover it. How will that money be used for transferring to anybody? No. So it is lost. Not lost. It's there with a person who is not going to claim forever. It's locked up with somebody. That's all. It's the same thing like a guy with $100,000 with him suddenly drowned and then went away and down under the sea with the money, and then that money is inaccessible and not. It's like that. Same. Okay. So we will come back after today's class may get extended slightly, but we will. Because we went on with the discussions. Now it is 8:26. It will take 15 minutes. 8:40, we will be back, and then 20 minutes discussion we will have and complete the 8:40 we will be. Hello, are you all there?
Yes, sir.
Okay, good. So let's continue. The most important aspect of this one, we will okay. So if you see, let us look at the output. The output will have a value field that will be, let's say, 0.01 or some Bitcoin. And then there is a second field, and this is called the script public key. Okay, script public key will be there. Okay, and in this, the following will be written: OP, DUP, OP, DUP, space, OP, hash 160, followed by 20 bytes, followed by OP, EQUAL, verify, followed by OP, CHECK, SIG. This is what will be written. You will see this in every output. With every output, you will see this. Let's see whether I have that transaction. Where is that? Oh, this is block 1. Let's say block 5 lakh. We will go back to what is all this? I don't know. It is, what happened to my key? This. Wait. Then it gives some transactions. Let us take any transaction. Okay. So you can see OP DUP, OP hash, OP equal verify, OP checksum. Okay. This is called PK script, right? Public key script. It is also called there is a PK. All PK script will have the same format. OP DUP, OP hash, followed by 40 bytes, 20 bytes, that a hash, the 160 bits. OP equal verify, OP checks. This will be there. Right? And then there is a, that will be in the input. We will come to that. Input will have what is known as SIG script. That is called the sign script. Okay. So this is what I told you. OP DUP, OP hash, followed by 160 bits, which is 20 bytes. Then OP equal verify, OP checks. This will be there always. So the sender has to fill this 20 byte part. Other than that, the format is fixed. Okay. So public key, the output will have the value, and then this is called the script public key. This is also called the cryptographic puzzle. Okay. Only those who can solve this puzzle have the access to that, to this money. So who can solve this puzzle? The person who has the corresponding secret key. Right? This is the script public key. I would mention something, and the one whose secret key, who has a corresponding secret key, can alone, right, open this, can access this money. So how does the system knows if somebody is accessing this, he is going to use this as an input. So he has to specify something which is capable of doing only with his secret key. The thing which he can do with his own secret key is signing. That is the reason why the input, this is output. Okay, output will have this. Input will have the transaction ID. It will have only transaction ID. In the transaction ID, the serial number of the output. Because there may be several outputs, as we have discussed, there is only one of the output that belongs to him. He will point out that it is that output value I'm going to use here. Right? Therefore, the input will have the transaction ID, the output serial number, then that portion he is going to use his digital signatures scheme, and then the algorithm he is going to use. So he is going to generate the sign script. So the signature will be generated. Okay. Transaction ID and serial number, and the portion related to that serial number, that part will be digitally signed. So when you sign, you get 256 bit, 512 bits. You would get all that 512 bits in hexa. When you try to use 128 hexa digit, you will get. So you will put that signature and some related information, right? We will call it as a signature field. Okay. This is called the script signature. This will be all there in the input. Okay? Because it will refer to that transaction ID, serial number of the output, and the script signature. Because signature is to be done on some message, right? That portion which he is referring to, right? This is signature. Therefore, this person is authorized to spend the money he got from this transaction ID over here. Okay. So how is this validated? How do you know that you are authorized to? So that would have specified his public key. A's public key would have been specified in this serial number output. Okay. This is the transaction from A to B. There is a transaction from X to A. That will have an output. That output will look like this: OP, DUP, OP hash. OP, this public key hash, that 160, that would have been OP hash 160, 20 byte. That would have been set here of A. Now, A is referring to the transaction, serial number of the output. In that output, this will be there. All the thing related to A will be there. Therefore, when verifying this transaction's validity, the verifying algorithm will be executed by every node. Everyone will verify. Because A has generated a transaction and he has flooded it in the Bitcoin network. His wallet generates a transaction and then it will flood in the network. Every node will verify whether this is a valid transaction or not. How does it verify? So what it will do is, I can quickly put this on page 38. Yes. So it will combine all of this, and it will do that in the following way. So the signature, the public key that is given by the user, and then DUP, and then this hash 160, and then that 20 byte. Okay. And then equal verify. And check signature. What are these things? These are all called commands. They are called script commands. Script is a custom designed language. C has got several operators, several functions, and then you have a huge library, and you can have header files, and it's a massive language. But this one has to be implemented on all gadgets, all operating systems, all kinds of devices. So a customized language, because there are only few things that we are going to do: signing, verification, bit representation, address checking. Like this, there are only some very special set of operations only we are going to do. So a very specialized language and its interpreter and the whole implementation of that is built in, right? You don't have to download the compiler or interpreter for this language. The name of the language is called the script. Script is a new language created for the sake of Bitcoin by the Bitcoin creator. Very, very compact and small language. It has got very simple syntax so that any simple system can implement. So system designers will be very happy to implement it. But then it has got very limited scope. You cannot find matrix multiplication, and then you can't solve some engineering problem with this language. With this language, you can do only limited things. But whatever you want to do in Bitcoin, you can do it. So it has got, as usual, operation and data. Operation will be denoted by OP. Operation. Op. That's opcode. OP and the name of the operation. The operation has a fixed syntax. For example, if it is plus, what do you need for plus? You need two data, 5 and 7. So give to plus, it will produce 12. Similarly, you need data for the operations. The data for the operation will be taken from a fixed place. It is called the stack. So you have, the language is maintaining a stack, and for every data it will put in the stack. Every operation it will pull from the stack and then perform the operation and put the value back in the stack. That is what it will do. So it doesn't do anything fancy, right? If it is a data, it will put in the stack. If it is an operation, whatever is needed for the operation, it will take from the stack, perform the operation, put the result back. That's all it will do. Okay. Microprocessor is way too complex. Microprocessor is computer. It has got instruction set, which is going to be used. If you write an assembly level code, you can solve any problem with a microprocessor. In fact, microprocessors only solve all your problems. Compiler is only there to translate C level code to that assembly code or machine level code. That your microprocessor is a full-fledged computer. Right? This is not. This is going to do only this. There is a stack where the data is available. There is a sequence of operation. It will pull out the appropriate value from the stack, perform the operation, put the value back in the stack. That's all it will do. So you have data, operation. Data will be available in. So there it is. Data or operation. All operations will have this OP written. If OP is not written, then it is a data that will be put into the stack. So what you do is, the verifier, when he is trying to verify this transaction, for input, A would have referred a transaction. In that transaction corresponding to A, there is one output. That output has got the signature, the public key of A. Everything will be there, right? The public key of A and other details are there. The amount to be transferred, everything. But this is only verifying the validity of the transaction. Okay. So what it will do is, the value, that SIG value, will be put in the stack. This is taken care. It will form the sequence. It will combine these two, and then it will form a sequence, and it will execute that in that sequence. So it's mechanical. There is an output, there is an input. It has to match. So somebody says the public key of this person is what is to be is the owner. Okay, and then he would have signed. So the signature and then the public key is also data. This will be put in the stack. Okay. This duplication is a command. What does it do? It duplicates whatever is the data that is on the top of the stack. So one more copy of PUB K will be made. This is the execution. This is the data. Data goes directly to stack. Operation is performed out. Okay. Duplicate. And then what you do is hash 160. Hash 160 is going to create public key hash. So it will take this copy, this value will be put out, this operation will be done, and public key hash value will be put in. Okay.
So this is the address, right?
This is the
Address.
This is the hash 160.
Of the public key.
Yeah. Of public key is what will be put here. And then the hash 160 value of the public key, right, is already given here. The hash, the public key value would be made available here. Right?
Okay.
Therefore,
Yes,
that
sir.
will be put the next to hash 160. So that value is there. Now, this is what matches the signature, the hash of that public key and the hash computed by them should match, so that it knows that it is only A who is accessing this information and A is working on it. For unlocking, A would have given this data. So next, equal verify will remove these two, right, and check whether they are equal, right? And now check signature. This is the sign verification algorithm. Sign verification algorithm requires the public key, right, and the message on which it has to be signed. So you have a transaction ID, the portion of the message you have, the public key is available. So it will generate the signature, right? And after generating the signature, it will put the signature here. Now signature verify will check whether these two are, because this has already been generated by him and then it is made available. Whether that and this are same. That is the signature check. If they are same, then the person who is authorized to take is what has produced the corresponding one as a signature. Therefore, this can be verified by a third party, anybody in the world. Therefore, all these data which is available in the transaction to all the outsiders in the world can execute this simple sequence of steps available in these two transactions. A is referring a transaction and generating a transaction. In A's generating transaction, he will have in the input, I am authorized, I am the person, he would say, right, and refer to the transaction. So there is a data. And here he says, give this to somebody. So this give this to somebody should have been set by T towards A. So that information and this his giving to somebody should match. So if C giving to A is a transaction T and A giving to B is a transaction T dash, the output of T and input of T dash the output of T and input of T dash will be lined up, and then this operation will be done. 5 operations, because there one is generating, another is verification, and putting the data will be done by the verifier using script, language, command, and stack. The script language, compiler, and other things are available. This check signature will work on that elliptic curve, signing algorithm, elliptic curve verification algorithm. All those things are built in, and it is a standard. It's not that I use one curve and you use another curve. You have to pass those things. No, all the parameters are fixed for those operations. Signing algorithm fixed, verification algorithm fixed, the curve is fixed. What is important is when you generate a signature as per that algorithm on the data, it should come to the one that he has signed. He has signed and introduced one. No, they should match. Therefore, when that you just check that, and when they are matched, then it is a valid. A is authorized by that person. It is that authorized person only is signing here and then transferring the thing. Therefore, this transaction is valid. So the validity of the transaction is done by the verifiers by combining these two and executing the simple sequence of operation in an identical fashion by everybody. This code, this execution of this script code is identical in all systems. It is frozen code. It is the moment it goes, the system, when it is parsing the transaction, right? It has various parts. From this part, take this output. One is called the locking script, another is called the unlocking script. Locking script means use your public key. So with output, it will be locked. When I say output, this belongs to the person who has the following public key. So it is locking script. Who can open it? Only the person who has a corresponding secret key with his signature proof, he can open it. That proof is provided in the transaction by A. But that transaction even I can generate. But I won't have provided corresponding proof. So if I use somebody else's and then use my key and then try to generate a transaction and flood it, the signature mismatch will catch that and then the transaction will be thrown. But when A produces signature, it will be corresponding to the message in that part. Thus, that part is visible to even to me as well as A. I can sign, but it won't work. When A signs, it will work. Because A is that person with the corresponding public key, the verifier will know this and verifier will approve. Only approved transactions will be maintained. It will qualify as UTXO. Unspent transactions that are verified alone will be used by all miners, will be used in the block, it will be put in blockchain and other things. Therefore, everybody would verify and keep the verified transactions alone. The verification process is a one-pass operation with a stack to maintain the intermediate results and data. So it is called the stack language. It is also called the script language, which has got very, very limited set of operations. I have seen only one. The entire script language specification is available in the Bitcoin homepage, right? As and when we require additional operations, here we have seen the operation of duplicate. We have seen the operation of the hash 160. We have also seen the operation related to checksum. Equal verify, checksum, duplicate. Duplicate simply duplicates. Equal verify checks whether two items are equal. Right?
Sir?
Yeah.
Just to clarify, hash 160 is basically turning 512 bits into 160 bits, right?
That's all.
Okay.
Because the public key will be given and then the public key hash is to be calculated. It is that
Yes, sir.
that will be appended as that 20 byte stuff by the signer. Therefore, whether it is the same as this, whether he is the person which correspond to that, right, or somebody else is trying to use his public key, that is not going to work. And then the signature that is produced, is that signature by this secret key, right? Therefore, the signature verification requires only the public key. So first checking the sanity of the public key, followed by verifying the signature and seeing that as a signature found, which is there in the script, in the transaction, that matches that, okay, this is a valid transaction. The transaction is done by the right person, right authorized person only has generated the transaction. Okay. Some more sanity check also will be done, whether the input is greater than, apart from signature verification, it will do a little bit of sanity check like this, and calculate the fee that is available, and that information will be made available to entire community. Everybody will do that because the transaction goes. As and when a transaction goes, the protocol will verify the transaction, and only valid transaction will be put in the so-called the UTXO pool, UTXO set. Okay.
Sir, what we just studied, the script language ka raha hai, it's part of the verification.
Yes. Script language is system executed set of operations. On that language, you are, of course, you can write some small programs. If you are a professional, you can combine them and then write some programs. That is what is used for writing the script program. And to that script program, you can give the input. Right? All those things one can do. But their abilities are limited. Where all the transaction data, I could see the, let me read that comment. All the transaction data are stored in the system. Same block that has got everything. Everything is available there. The whole block. That's why blockchain scalability is a problem. You have to physically maintain a copy of that, and everybody maintains the copy. Right? All transaction, all their data, everything is available all the time.
Sir, in this case, we retrieved the 5 lakh block, no? So from which node we got this data?
That we don't know. That software which is maintaining, he may have a local copy. That bitcoin.com, that web server which is giving the user interface software, that may be a node. Okay. Or it may consult a node and then it can retrieve. So I don't know what they do. Mostly it will be a super node that it will have all the data, it retrieves locally, because the response is very fast. It should be a local copy.
Okay.
This copy is available, identical copy is available in 10,000 nodes across the world in the Bitcoin network. Bitcoin network is a super layer of the internet. Some of the nodes of the internet nodes are Bitcoin nodes, and the same internet connectivity is used for communication. So it is built on the top of internet. It's not a private
node is basically every device involved in this, right?
That's
this
all.
blockchain?
No.
Yeah.
Node is a device which is holding all the Bitcoin related data, the blockchain, the software, the packages, all those things. If it is called a node. Your laptop could be a node. A supercomputer could be a node. Right. So we will see more detail about this in our next meeting. Okay, I'll show you physically how this is done, and then where all these kind of things. And in the meantime, you examine the body of the transaction, examine the body of the thing, see what are all the information that are available. Everything will be explained. But right now we are focusing on transaction verification and validation process. We have seen about transaction fees. We have seen about input and output transaction. We have seen how they're structured on. The most important part is, apart from the data on value and other thing transferred, the locking script and unlocking script. Locking script means I say that the person with this public key alone can use this money. So the transfer of ownership is done in a way that I own the money. Now I am saying that this money can be operated by the person whose public key is, and I specify that and then put it in public. When that person wants to use it, he can refer to this and generate a signature on the relevant portion with his secret key, which only he can do, and put that in the input part. And from this transaction, some money he can give to somebody else. Now, his input part and this output part information must match. How is that matching done? There is a simple verification process which pulls the two pieces of information from previous transaction, three pieces of information available in the current transaction, and sequences it and executes in that order those 5 instructions. That is the validation process of a transaction. That's what we have seen so far. I'll give the more detailed explanation of this, and then we get into some data information related to transaction, several other useful things about transaction, and some more advanced instructions and use of transactions in our next meeting. Then we will go on to block, then mining and other things, and then we will conclude. Okay, so blocks will take a couple of meetings, and mining and difficulty adjustment, and then how the system works. There was a question asked, who mines it, and then how it is mined. That will be there on the 7th meeting. We will have tomorrow in the next meeting about of the part will go on, probably full part will go on transaction if it takes more time to explain and other things. And then we will go on to the blocks, blockchain, mining, and conclusion. Okay. All right. So let us stop at this point and we will continue our discussion next.
Sir, I'm audible. Hello. Sir, I'm audible.
Yes, Ethan, you're audible.
Sir, can you share us your email of numbers so that we can ask any questions related to this course? That's fine.
Ethan, I'll forward your request to him.
Okay, thank you.
Yeah, thank you. Everyone, please provide the rating. I've dropped the link in the chat box for today. And post that you can we can sign off. Thank you for joining.
Hi, Shishmita.
Yeah.
Shishmita, tomorrow's session seems to be a lab, right? So is it going to be a working session or is it going to be a training session tomorrow?
Yeah, we'll just confirm it with Sir because Sir said he wants to cover a few topics. But we'll cover up the lab. Don't worry about that.
All right. Are there any prerequisites with respect to the system and all, Shishmita?
No, not currently. So in the later labs, if we need something, I'll be forwarding a proper document of what all you need to install prior hand, but not for tomorrow's.
All right, fine, thank you. And Shushmita, can we just have this by when can we expect this one to be uploaded into our into the site?
Yeah. So at least 4 days prior to the lab, the requirements would be given so that you have ample of time with you.
Absolutely fine. No, my question is the session that has been completed now. When can we expect this to be uploaded into the teachables?
Yeah. Sachi, you want to take this? Sachi, you want to take this question?
I can take this question.
Yeah.
Sushmita.
Yes, Jay. Go ahead.
Hey guys, good to see you. Thank you, Professor Pandurangan and Sushmita, and everybody for the valuable time. So first, Naveen, so I think if you've seen the previous time to upload, I think we're doing it by Tuesday, Wednesday. So that's pretty much the cadence that we're keeping, the periodicity.
All right, okay, yeah.
So, okay, first off, how many of you have submitted all the quiz? If you've finished the quiz, type Q here. Type Q in the chat box. I think everybody can have access to type Q. Okay. I don't want to be the bad guy. I know you're having fun in this course, but if you don't submit your quizzes and if you're not attending on time, we're very strict about the certification. Yeah. So I would really want you to take this very seriously in terms of the criteria, etc. I want everybody to type Q, finish it by the time. It's an intense program. By now, you would have understood the subject is difficult, which is good, which is normal, right? If it's coming easy to everybody also, that's not really valuable. So awesome. I would please type 100% if you're going to be, I want you to be committed, super committed to all the sessions, all the labs, all the classes. And I know some of you asked Professor Pandurangan's email. Here is his email. Feel free to ask him, loop us in the email. And I'm sure he'll be kind enough to respond to your, Sushmita, why don't you drop your email ID as well? Whatever questions they have, we need to be, completely, Satyam, like I said, see, recordings by Tuesday, Wednesday, we'll upload. Yeah. I can't have an SLA before that. I hope you're clear, right? About that. I'm sorry you missed the session, but it'll be by Tuesday, Wednesday. I'll tell you why also, because this is not the only course we're having, Baba. We're having other ones as well. And we just need to just keep, basically, we just need to be edited and etc. There are minimal edits, but just that the team. So by Tuesday, Wednesday, you'll have it as much as possible. One more benefit you have is this is being live streamed right now on YouTube as well. YouTube, LinkedIn, Facebook. We cut off. We are going to pull down the recordings by Tuesday, Wednesday. So you can directly go to Pixel Test, subscribe. It's available for free as well. Everybody clear? Type CLR, guys. Now, before we go, and I really
then,
want...
Jai sir, then if you are giving free in YouTube, then a lot of people we are paying, no? That's why.
Bharatesh, please listen carefully. What I said, sir, is it will be taken down by Tuesday, Wednesday.
That recording, this thing, recording of this one.
Yeah, the live streaming.
Okay.
Right. And one more thing is you get out of this free mindset. You're paying only for accountability, right? We pay to get whipped. Right. We pay to get whipped only. The more you pay, the more accountable. That's it. So like it or not, that's the thing. I said by Tuesday, Wednesday, we'll remove it, turn it down. Because some people like, Satyam and all, and Hiten, who are, a lot more proactive. We don't want you guys to miss classes, right? Don't worry about what others are doing, free stuff and not free stuff. Just hyper focus on this course. It's a beautiful curriculum. By now, you've understood. Sky is the limit. Get a thorough grounding of the sciences. Okay. Second piece is I want, Sushmita, one of the things is I would request you need to take feedback, right? I want you to take feedback because, we're adding more modules, more prospects who come. Again, this is a community, right? Please finish the 5-star rating and the top 3 takeaways because it's fresh right now, right? Are you clear? So there are 20 people now. I need 50%. I need 100% of the people to type the feedback and only then leave. Once you finish IOS and you top 3 learnings, and don't just write course is good, sky is blue, India is developing country like that. Please genuinely write what you felt today. Heavy topic means it's heavy. Comedy topic is comedy. Sad topic is sad, right? Please genuinely write like that because the prospects you're getting, the other people you'll be getting, etc. By now you have seen it's a very diverse the gamut of course is very, the crowd is very huge, right? So new people who will come, they'll be lifelong. You're probably your co-founders, probably your partners, probably employees you will find, so on and so forth. Everybody clear on that? So I got four 5Ss, the 20 people minus the 3, 17. I want all 17. My request is that everybody finishes the feedback. I think sir is still there. Feel free to ask Sushmita and me any questions. Obviously, Sushmita is the more technical person in this case. And one of the other small feedback I had, with your permission, guys, is just keep your video on. I saw only Hiten was having the video on. If you're not having a video on, my presumption is you're not going to be serious. Every ounce of your body, mind, just completely surrender to this. Let's play some nice, cool music. Meanwhile, Professor Pandangan, sir, are you there? I think he left. His iPad is there. Thank you, Karan. Thanks, Balveer. Thanks, Jairam. Thanks, Baltesh. Thanks, Shiva. Sushmita, can you also, small favor, just share the screen on the upcoming topics? I know sir mentioned the upcoming topics. I was also listening to some part of the class so that everybody is clear about the future. Quizzes, I think the periodicity is by Wednesday, we'll be uploading the quiz. I hope that's okay. And one more thing is I've listened to some feedback. Yeah, sorry that Telegram group is one way, but I think we're going to move to Discord. How many of you have heard of Discord? Type DIS in the chat box, guys. Yeah. So we'll mostly move to Discord where there's the free community also. The self-paced community also. So I want, the idea is why we didn't make Telegram is, honestly, I'll take that as my mistake, because the critical mass is too less. What will happen is only 30, 40 people. And most of the questions are also, I'm getting like questions like how do I access Teachable? How do I get Telegram? It's kind of sad that most of the questions I ask is how to access Telegram. Like, this is the most futuristic technology possible, and you're asking me about Telegram and email, and that's kind of, I would request all of you to urge and go back to yourself, like go back and reflect on yourself, right? So let's move to Discord, because that's where the best of the people are. Give me some time. By end of the week, we'll have Discord with server with few channels. Week means not this week, the upcoming week, and we'll have like the pieces there. There's a little bit of learning curve for those of you who are not familiar with Discord, but you have to upskill in Discord, because Discord is where all the blockchain world is. Cool. If you're clear, type CLR about the Discord. Give me some time. We'll be moving there shortly. Yeah. Whoever has finished the review can kind of leave. Let me just play some awesome music. You can leave. Yeah. Satyam's question is good. Sushmita, you want to take that? That's a good question.
Yes, Satyam, we can get that. Probably I'll upload a PDF of this list of questions, and also quiz could help you to just revise through all the topics that we covered today. But yeah, in the labs, we'll be having this assignment also, a couple of assignments.
One thing is, Satyam, if you're, why don't you get started with the quest book? My request is, why don't you get started with quest book right away? Sushmita, you have the link of quest book. Can I request you to just paste that right away? I think some of the other members, Mohit and all, have started off quest book. That can be a parallel track if you have more wherewithal. Have you heard of quest book, Satyam?
Yes. I've heard of quest book. The one which you gave on mail, right?
Yeah, same thing. How far are you in there? Like how long? What are you doing?
Yes, sir. Actually, I have tried some questions. Not complete. I think 4 to 5 not complete.
Yeah, it's okay. It's okay. Keep struggling a little bit. By the time we intercept, that will be from a month maybe.
But that quest book is about like solidity, right? I mean that spins. I'm asking the cancer which were taught today.
Got it. Yeah. No. What I'm saying is two things. The assignments, the quiz are definitely tuned to this subject, right? The assignments, I think, Susmita, I don't know if you have any more hands-on in plan, right? I think she's answered to to
Yeah.
that.
Yeah. So I'll be sharing one PDF also with some additional assignment, which would be apart from lab, which would complement today's session also. And also there would be quiz, which you could go through to revise what all happened. So these two things would be given. Yeah.
I mean, I don't want to give you two dichotomies, like two sides of the coin, but if you have additional, I mean, I love the sciences part that sir is teaching, which is obviously a very fundamental grounding. But I would, if given you have any additional wherewithal or time, I would straight away focus on utilizing these concepts for the solidity or the rust. Because the goal is, I mean, as much as we all love sciences here, what is our ruthless goal? To become employable, right? Like, and so let's work backwards from that. Like, it's great to see all of these, and I love it personally, but you also have to be market ready. So I would straight away also go to that piece right away. Because core fundamental sciences, you can keep going down and down and down, and you can get even a PhD, but that doesn't mean like that's not really the outcome of this course. If you have any bandwidth wherewithal, you have to have the mental discipline to like learn this, ace it, ace the quizzes, ace the class, but immediately shift to like, the quest book, the hands-on piece. Yeah.
Just to extend this further, it would be really good if you could start with some of the projects. If you need to brainstorm about the project, small project ideas, you could start, because this you could put on your resume and you could say that you didn't just attend it, but you also had something hands-on and you implemented it. So if you want something on these lines, I have dropped my mail also, and also you can contact Jay for it. I'm dropping it again, so that we could get in touch and we can work on these lines. Because again, the audience is quite diverse. So just getting purely coding, that's why sir is like, keep maintaining the balance. So, but if you are interested in purely code area, let me know. We can do it off shelf. Yeah.
Yeah. But so we are going to be covering that, but not now. It'll take at
Yeah.
least 4 more weeks to intercept to that level.
Right.
Cool. Again, I would request everybody to just drop your feedback. And those of you who have dropped the feedback, I mean, thank you for that. If you finish that, type 5S with your top 3 learnings, guys. How many of you are in Bangalore? Type me. I'm just saying that because there was Build Space conference today about Web3. Web3 is different, right? I'm just saying. I just came for that too. Okay. Batash. How many of you followed the blockchain conference in Dubai? Okay, slowly start getting involved. For 90 days, don't do anything. Of course, sciences is very important, but you should also be little aware of what's happening. Not now, but a little later. Because first is the mental mindset. How many of you are listening every day to Stranger's Secret, Earl Nightingale? Type SS, Stranger's Secret. Twice a day, every day. Don't worry about coding. You will not become a blockchain engineer or an AI engineer if you can't conquer your mindset. You can kiss that goodbye, guys. You can go to 100 courses, but you'll still be. I would request, please rewatch orientation again and again, again and again, again and again, again and again. Your goal book, I carry my goal book everywhere. It's just the same thing again. Like I said, the SBI Bank, same goal. Just again and again, again and again. Sorry, this thing is, there's nothing new, right? Just do that. I've told it in the orientation, please do that again. Anybody who's not watched Success Mindset, type SM, please. SM. Yeah, please watch Success Mindset. Do not write a line of code. Do not even come to this class. If you can't fix the mindset, guys. The goal of this is not to have a lucrative career. The goal is fulfilling and lucrative career. Again and again, again and again. Please watch that. That's part of orientation. How many of you have watched Nitya Shanti's and Mind Reflections of Life, that interview? It's on YouTube as well. Good. Thanks, Satish. I saw you there. Yeah. Watch it again, again and again. If you don't have a ruthless obsession, not love, not lust about your mindset, it's gone. My request to you is that I will touch your feet. Just be possessed about your mindset. And there's nothing, mindset is your mindset, not my mindset, not your mom's, not your dad's, not your spouse's. You might think I'm cuckoo, but that's the most important. Karan, you bought Unburdened. Great, great. I have to meet him in Pune. I actually, thank you. That's awesome, man. Brilliant. No, Chandar, I won't share the link. It's there on YouTube. Please search for that, yeah. It's there on YouTube, sir. Just go to Nityashant, go to Pixeltests, like YouTube live lectures. There's like that. Actually, it's a good one. Let me share it. You can miss the tech, but I don't want to miss these. One more thing is, most of my material is free. Most of my best material is free. There's only one session. Yeah, I sent it to you. Okay, you got it, Chandar? No problem. Yeah, it's a good session. So I didn't want to like give you more friction of going and searching. Contrary to perception, most of my material is free. Guys, remember, you're paying not to us, to yourself to get whipped. This is Kali Yuga. Some of the most, like Earl Nightingale says, the most transactional things are transactional. Like in the sense, he says like some of the best things are free, right? Like parents, kids, love, but we don't value it. Only if you pay, you value it. So same thing happens with me as well. Anyway, that's philosophical. Coming back to this, so lessons are going to be updated by Tuesday, Friday, Tuesday, Thursday, Wednesday. I'll keep the Discord server. Give us some time. There you can have more interaction, even with the new members who are coming in, because there's flush blood coming in. I would, if you have little bit, even 10%, if you're ahead of this course, which is great, you have wherewithal, just go and start the quest book, start activities, get immersed in other communities. Coming back to this, I think Sushmita is on track about that. Please fill the Trustpilot score, and I request everybody to watch Success Mindset, which is an orientation. Go back and watch it twice, thrice. Some people have watched it 7, 8 times. Without that, it's a waste. And watch Nitya Shanti's interview again and again, again and again. The goal of the community is not if you become rich and fulfilling. There's a specific way to be humble forever. All right, anything else, guys, before I will call it tonight? Feel free to just reach out to me if you have any issues.
This recording is available in LMS, no, sir?
Yeah, but everything is there.
Okay.
See, one more thing is this basic hygiene, yeah. All recordings will be there in LMS. Otherwise, I won't get accredited. I'll be honest with you. IIT-Madras has given me this beta. They told me that if you don't do the course well, the next batch won't be there. So we are following a Six Sigma principle. Okay. All major support tickets we resolve as fast as possible. Major support means, oh, you know what, my teachable access is not there, my password is not there, my second socks are not found, not like that. Like real proper.
One more thing, Panduranga sir, they write down their notes in the while they explaining. We need that one also. When we go through that session, we are able to understand what they're explaining. When you go through again through recording.
Yeah. So Sushmita, I think we have discussed. So you are also capturing this as a PPT, right?
Yeah.
So we are going one step ahead. How many of you have seen the PPT lectures as well? Type me PPT.
PPT is not yet shared. It's not on the Teachable. Yeah.
Oh, it's not on the Teachable. Sorry, I my bad. I thought it was on Teachable. So when do you anticipate that coming up?
Yeah. So probably by next week we can upload all the details. I was just waiting for this module to be completed of the basics. So I think we are good to go then.
Don't do that. Yeah, I mean, great idea, but don't do that. Just iteratively keep pushing. Keep pushing. 1 week, just keep pushing. Don't make this perfect dinner. Right? Just keep pushing. Don't optimize for success. Optimize for failure, less failure, less failure, less failure. Just push it. Because otherwise the talk will be like, oh, you didn't upload. See, that's what they're saying. So you and me can't have a discussion and, audience has another. Just upload whatever is there. Okay. And request maybe Pastor Pandurangan to get the PDFs also. Because it'll be on his iPad.
Yeah.
Hey, can you make me co-host access? Sorry, stupid question. Okay. Anybody else who is left with 5S, please let me know. All right, cool. Then I think we'll call it a night. Thank you, everybody, for the time. Good to see you, Satish, sir.
Thank you.
Regularly coming in, working on that mindset. Those abs on the mind.
Yeah, I'm aligning myself. Yeah, all the young chaps. So I need to pull up my socks really hard.
Okay, very good. Good night, guys. So tomorrow we'll see you at 6 p.m. You see also one link only. There's no more multiple links, multiple emails, Telegram. See, the primary communication is email, guys. Email is going to be your communication in MAN companies also. Telegram is a bonus that we have just kept. Just follow your emails, put it to primary. Okay, cool. Thanks. Good night, guys.
Good night. Good night.